Hello. Good afternoon. I hope you enjoyed the lunch. You're ready for new sessions. My name is Jovan Strika, and I'm representing Mikrotik. Mikrotik is a supplier of networking equipment and management services, and really built around and for Mikrotik devices. And today I'm going to talk about a unique approach that we took for network monitoring services, and how we leverage the Mikrotik scripting capabilities to achieve network monitoring. So I'll start with a few just the basic slides. What is network monitoring? What are the available solutions out there? What do we recognize as the challenges? And we'll talk a little bit about our approach to the problems, and then I'll dive into some code examples on how we did with the scripting. So what is network monitoring? So network monitoring means continuous monitoring of the network devices and its performance. Typically it's there to identify if there is any problem, any outage. It's using different kind of messaging system to inform about alarms and states of the devices. And it is definitely an essential tool for internet service provider, managed service provider, but also for businesses either with multi-site or single-site who are interested to know the health of their network. So when we look at what are the solutions available on a high level, we kind of split them in these three categories. There is open source or free type of monitoring solutions, and we all know about Dude and Nagios, Zabbix, and the others are available there. And the good side of that is there's no really software cost, so it's very easy to get it installed, but you need the hardware and typically a dedicated machine to run these applications. So it just comes free, and as well as there's no support. So you're kind of on the mercy of internet and other ways to get help. Where on the commercial side, you have the paid systems that, in some examples are NetEngine, SolarWinds, Scrutinize. Again, there's many more. As you know, this space has so many vendors out there. And the paid one comes with the support. So you have somebody to call if there's a problem, but they're not free, and you still need hardware to operate it. And the new category that kind of emerged in the last 2-3 years is the hosted or cloud-based providers. They're selling not just the software as a service, but in a way hardware as a service as well. And some of them, say, traverse uptrends, they're all emerging almost from the middle category, from the commercial pay. They still provide some kind of a software version as well, but they end up installing this in their data centers in the cloud and then offering that as a service. And you do have support, but there is no need for hardware, because they take care of the hardware piece, and you pretty much pay per interface is the kind of a mostly adapted model, which can be quite expensive over time. And when we look into kind of this space, if we reflect into very basic simplified network diagram, where you have this central location, it doesn't matter if it's open source, paid, or hosted, and you have remote sites, in this case 2 routers that you would like to monitor. Typical model for almost all of them is using the 2 main standard protocols, ICMP or ping to identify if this device is online, and SNMP, Simple Network Management Protocol, to gather the interface data and performance statistics. And what we used to call, this is almost like a pool model. What it means is that a server initiates the request to the remote sites and pull the data and store them in a central location. Well, the challenges that start appearing with this model is, first, static IP address requirements. Most of them are expecting host to be with the IP address, which means that the router just down there has to be with the static IP address. And there are workarounds to this problem with using dynamic DNS, so you can sort of propagate the local static IP address to dynamic server, and then configure the monitoring service using the domain names rather than static IP address. But the problem with this is that you can end up with the false positive scenarios you can end up for the server, device can appear as offline. Well, actually, it's really just got a new IP address, and it's propagating DNS, and you get notification that the site is offline, which actually is not. So that's one of the challenge. The second one is limitation of what we call the double NAT scenario. Network translation happening on the router and kind of traversing the LAN private network into the public. More and more we're seeing ISPs implementing the second router in the data center that again translate this into real public IP addresses. And the main reason is because, as we all know, IPv6 is there, but still not adopted as much, and IPv4 addresses are gone. So ISPs are using now more NAT as a way to provide access to the other devices. And the challenge is that if you would like to configure a monitoring server, you don't really have a public IP address anymore. And if somebody locally would like to be, get a static public IP address, typically they cost more, or they even have to change completely the type of connection, which can be quite expensive. So that's a huge problem of how you can actually reach the device, and there is really no workaround for that scenario. Another challenge is having the firewalls. We start seeing more and more in the last couple of years ICMP and SMP blocked. So you cannot get to the router even if you have a static public IP address on the device. And once you connect to the device, you don't really have a good access control levels. SNMP has its community and password that you can access, and you can decide if there's only read or read and writes, write writes. But the challenge is that you cannot limit what will be given away to the monitoring service. So pretty much whatever the router, what kind of MIPS support, meaning the data that can be delivered using the management protocol, everything is available for whoever is monitoring. And again, if somebody else take the access to this device, they could retrieve the data, although it might not be immediately used for security breach, in conjunction with other things could actually create security issues. And when I look at access control, there are typically limits by IP address. So you can say, I will allow only if the static central location has this public IP address, I will allow only from that IP. But the problem is, if anything on the network side, on a central location, end up being changed in terms of a different IP address, or maybe if they have a redundant system, end up failing over to the different cluster or different data center, then usually you don't have a kind of list of the IP addresses that you will allow. It's typically only one that you will allow access. And therefore, again, it creates a problem. And this data is unencrypted. So all the communication between the monitoring server and the routers, it's all going over public internet, and it's unencrypted data. So that also is becoming another challenge. And then the last piece is really limited, or I would say no backup capabilities. Typically, the systems are built to be more generic, to be compatible with the different vendors. So in this case, you don't have a centralized standard how the backups or configurations will be stored, and therefore they don't really go into that area. There's no way to have a central location where you can retrieve the configurations for all your devices and then being able to recreate in the case if there is outage and you need to rebuild the device. So when we look into all these challenges, we kind of put in front of us a different approach and said, okay, we're going to use the push data model rather than pull, meaning instead of server connecting to device and retrieving data, we're actually creating a sort of an agent sitting on the router, on the Mikrotik device, in a form of the script. And that script is getting executed directly on the board, so you don't need a third-party application, server, and software running on it. And what it does, it actually sends the data to the server. Now, the way how we're doing it, we're actually using HTTP protocol. We are firewall friendly. HTTP is not blocked by any firewall, otherwise nobody will access internet. So in this case, we are bypassing any kind of firewall issues, and we're sending that actually using SSL. So it's really HTTPS protocol, meaning all the communication is completely encrypted. And at the same time, where the destination is, well, that can be domain name, and that domain name can resolve to different IP addresses. So if we need to fail from one data center to another, it's completely transparent for the router, it's resolving the address, it's connecting to the different locations, so you don't have really a limitation, and you don't have a challenge with the access control, because we're sending only the data that should be sent, what is relevant for user and for the device. So it's not like SNMP, you have access to everything. And then at the end, it's very low processing overhead. It was very important not to create an application that will affect the throughput and CPU on the device. And still, we had to meet the basic requirements. So centralized view of distributed devices, whatever and wherever they are, so it can be on public internet or behind the double net and located in the ISP private intranet. So as long as, let's say, wireless service provider equipment can reach out interface, so therefore there is a routing in place, it will be able to send the data to the central location. We need the device status monitoring and obviously alarms and outage notifications. The network performance metrics was important, but not only from the WAN ports. Okay, we want to definitely know what is the usage. Well, first of all, we don't want to use only one. There's more now WAN ports evolved. We have a failover to 3G LTE. We want to know what is the potential usage of that WAN interface. So this has to be able to take multiple data points in different interfaces, as well as a class of service. And that's part that I had a chance to elaborate too much in this presentation. That we want to know also out of this bandwidth that is going through the WAN interface, how much is used for HTTP, FTP, voice. So in this way, sort of using the manual rules and different queuing mechanisms, we will be able to then collect the data and understand usage based on the class of service. And then we definitely, historical data, you cannot really, without having a history, do proper analytics. What we want to know, if there is a usage of 95% on the interface, well, that might be normal if it's a Thursday 1 o'clock time for monitoring. But if it's in the middle of the night, you don't want even to see a 10% increase. So it was important to compare historical, what is the usage of that port, and know when to actually create the notification. And then at the end, it has to be able to configure, to store centrally configurations, and clearly the portal and use of this should be web as well as mobile-based. And there's a kind of requirements they put in front of us, and then when we look into how to achieve that, well, the scripting is the way to provide these kind of services, and I'll walk you through several different commands, not dive into full code, but at least snippets of what are the things that we use then to achieve that. And kind of before I go to the code, we need a Winbox. So I think there's 3 people only here that don't know what a Winbox is, but I'll mention this is the utility to connect to the device. What you see on the right is the actually screenshot of the Winbox connected to the router. And these 2 windows, one is the terminal where you can actually execute the commands that are going to show and kind of get a response. But if you want to create a script and store this, you have a way to create a new script. And what you see is a kind of a very basic editor that you can type your commands and then run in a script from there. But that's kind of your basic environment. If you have any Mikrotik device, Winbox tool is available from Mikrotik. You can download and then play with it. So to go into commands, we're going to talk a little bit about script and scheduler, patch command, how we use the global versus local variables, how we gather the information, and then how useful or not the monitor traffic command is, how we get a bandwidth and average use, and at the end send the data to the server as well as the configuration. And in the end, I'm going to, if there is a time, mention a little bit of what are the challenges and what are things we need to kind of address on the server side, because at the end of the day, it's having a monitoring service without a robust and reliable central location, it's kind of useless. So I'll bring this a few challenges at the end. And so the first system script, I mean, that's the command that, in this case, creates the very basic script called log test. And what it does is it creates a log message with a content test. Script is the way for automate different operations. So pretty much any commands that you can execute on the board, you could actually save it and store it in a script, and then use that with what we call scheduler to actually execute this on a specific time or period of time. So what we have downstairs is a system script schedule. It's actually creating every hour, initiate the run of that script, and we will every hour get a log message with a content test. So that's a kind of a basic start. Then what are the tools available? So there's a couple of tools that we kind of used to achieve that. One is the fetch tool. So the tool fetch is actually really used to get the applications or information from the internet. In this case, the fetch tool will download the net address to PDF and store it locally on the router in a files directory. And it's using the HTTP protocol to connect to it. But you can also use HTTPS, so it supports the encrypted communication as long as your server has a proper public certificate. And it will, in this case, send the request to server, but we are using what we call the get command to actually really post the data. So what we're doing is sending to the server in a variable message with the content hello. And the next one, what we have to use is the variable. So I'm going to put on the end how we kind of connected all these pieces together. But before that, I kind of wanted to introduce what are some capabilities of the scripting, and variables with any development are critical. What Mikrotik supports is local versus global variables. So in the local, in this case, we're defining my local message with a content hello, and then we can again use the log command, but do the reference to the variable, and it will output the hello command. And on the global, works exactly the same way, but the advantage with global is that they are shared between the different scripts or different instances of that script or in the different executions. Where in the first one, when this script is finished, if you start again, they will not know about a local message, where if you define in a global scope, then that variables will be known, and you have to just reference them and then access their content. So we'll see later how we kind of use this local versus global. And then for the traffic, we put a lot of thought about how really to retrieve the statistics for WAN interfaces or any other traffic instances. And we start with the interface monitoring traffic tool. It's a built-in tool that gives you, in this case, a bandwidth throughput of the Ethernet 1. And what you see is the kind of all the main statistics, receive or transmit packets and drops and errors and bits. And in this case, we're getting 3.4 kilobits per second throughput. But the problem with this is that it's real time. Meaning if I execute the same command the second after, I will not get this data. I'll probably get 2 meg per second. So that definitely was not useful for really getting an idea of what is the throughput in the interface. So what we had to do is to actually look at the averages and to calculate the average of usage between the different executions. Then we do this kind of in 2 parts. First, you need to know when was the last time script executed, and we use the last time variable where we reference, so we get the last time when it was executed. We then look at the current time minus last time, we get a difference and know what is the time since the last time it was executed, and then store that last time for the next execution. There's a lot of times there, but the bottom line, we know how much time passes between the different script executions. And then on the second part, we're doing a similar, but now with the data. So we stored what was the previous total accumulated traffic per interface. So in this case, we're referencing again, we're taking now the new accumulated traffic, we're subtracting and then dividing by the period in order to get actually the throughput, the average throughput between these executions. So if we're doing every 5 minutes, we will end up getting the average of these 5 minutes, and that's what we actually end up storing. The good flexibility with this is that you can, if you put a script to do every minute, then you will get more resolution and more precise throughput per minute. But at the same time, if you're storing everything, then there will be a huge amount of data on the server. I mean, just every 5 minutes submissions to kind of average type of router that we use that has maybe a 2 WAN interfaces and no class of service, we're talking about a 20 gig per device to store 3 months of data if you do only 5 minutes. But the data that is submitted, it's actually not taking a lot of time because it's doing every 5 minutes and it's a very small chunks. So when you look at what we are submitting, besides the WAN interfaces, we also need the statistics of the device. So we're taking the board, version, platform, and there are different commands that actually allow you to retrieve this data, store in the local variables, and then we use the previously introduced fetch command. In this case, first one we're sending it device info page, and we're submitting the board version and platform information. And the second one, we're getting the kind of statistics of the WAN interfaces. And then server does the all accumulates, see analytics from the previous, and then knows if firmware was upgraded, sends notification, or if WAN is overused, and etc. So that whole intelligence is moved away from the board into the cloud. Therefore, we were able to achieve very light processing on a device. And it's compatible with any Mikrotik device. It's not a specific cloud versus the small access point. Every single Mikrotik device can execute these scripts. Therefore, it's compatible with any device. So the last thing was the backup. So Mikrotik has 2 commands. One is the system backup, the other one is the export. Backup creates the binary file of that device, and the export actually exports the text readable group of commands that basically allow you to recreate a configuration of the device. And that was really critical because what happened is if device ended up being defective and we need to recreate, or maybe that device does not exist anymore because Mikrotik end of life that device, we have to put a different device, we can use the export to rebuild it and then send the new device, and pretty much all they do is kind of rewire on a site. So using that, you eliminate the need for customers to keep sort of a second copy or backup when they have a mission critical operation, and this case can rebuild the device very quickly. So what was on the server side? I will not go in details on that side, but a couple of challenges. First, you need to think about geographic different locations, and we're kind of looking to being closer. It's more important. Part of the statistics that you can do is also the internet response time. So you can, similar in the script, execute say what is the ping, and then you get a response time, and then submit that, and that can give you an idea of if there's a latency on the interface as well. So clearly, what you're testing should be closer to the client. So closer you are with your clients, and it's important to have a better statistics. Obviously, load balancing. Once you reach the server, has to kind of balance between the cluster. More data you have, you want to throw in another machine or spin another VM that will do the processing, and processing has to be real time and kind of evaluate data quickly. We use the NoSQL databases because the schema was important to be flexible. You can have one router with one WAN interface, the other one with 2 WAN interface and class of service. So we had to stay away from the typical column in the rows model that traditional databases have. And then obviously replication is critical in the case if one system fails, then other ones can take it over. There is distributed storage, very important as the data grows, as I mentioned, adding the devices. And we use kind of really latest ways with a huge data or big data approach with Hadoop and other systems to address this. And then obviously indexing and fast search and retrieval of data is critical. Having some kind of caching and pre-processing, it's really important to get a response fast. most of the system out there, they run fast and great when you just turn them on. When you start having a lot of devices and a lot of history, that's where you start seeing a problem with working with the data. So at the end of the day, the system is unusable if you submit a request and you wait 5 minutes to get a graph there. So that was a critical challenge. And then addressing user access control is really more from the on the server side and not on the router anymore. So you have more options to see how we're gonna limit it and what they can see or not. This is just an example of the page that you can in the end gather, and this can be your own page with your own server if you're building something like this. But what you want is kind of one snapshot of what is the data, what is retrieved, and how it looks, and more importantly is the graph in terms of the bandwidth usage and throughput. So that's really what I had for these sessions. I know that there was interest in a management aspect as well. You have to come to the next room so that you can hear more about management. But I'm going to give you just a kind of an idea and a snippet. What is really interesting with the fetch command is that when you are sending the data to the server, you are getting response from the server. And that response is actually stored locally on the device. And what the advantage is that you can use that as a way to manage and to submit configuration commands to the device. And that's really was critical because because of the same problems that I explained for the monitoring, you might not be able remotely to access the Winbox or SSH device. So this way we can actually use the similar method to do the configuration as well using fetch and at the same time do the monitoring. So that's all I have for today. Thank you.
Just one. On the keeping the statistics like every 5 minutes, have you thought of, or is there a way to have 5 minutes for the first week, but then for the month, take those statistics, compress them into just every 30 seconds? I think, yeah, 30 minutes.
Exactly.
MRT, I think it's the one that does that.
Yeah, exactly. And that's the part of pre-processing where as you're longer, trying to kind of reduce 5 minutes into 15 and later to an hour, and so that you don't have so much data. But at the same time, everybody sort of wants to see detailed on 3 weeks ago, and that's where suddenly you have not as high resolution. But yes, that's the way that we kind of try to minimize the data.
Okay, but can you configure that in a way that if you
want,
or is that hard-coded?
Yeah, it's currently hard-coded. We didn't thought about that, but certainly that's possible. And the challenge a little bit with the data is how you notifications might not be the trigger at the same time. So we put a lot of thought about, okay, maybe this one is not a reliable connection, therefore I don't want to be alarmed every 5 minutes because I know that it might be not as reliable, where other ones I want to. So there was a more about that. When is the triggers that we thought about it, but not about configuring the compression sort of mechanism. So that really
I operate a little bit of a non-standard setup, and we're an oil and gas company, so I don't allow internet access to my field sites there. Is there some kind of thought or plan for having like a local agent that would be able to collect all that data and then forward it to your systems?
Yeah, so clearly this is a portable method. I mean, it's not. This is really more about capabilities on the Mikrotik side than actually capabilities of our centralized cloud services. So clearly that can be in-house as well solution. There's no reason to not to have. Although most of the devices what we see is could even create just a output rule and route just for that hitting the central location as a kind of workaround. It's all balanced between do you really want to host internally and have a cost of maintaining that versus having it as a service, and that's obviously a balance that depends on the infrastructure. Now, I really want to highlight that the scripting gives you way more functionality. So these don't have to be just what I mentioned. There's so many possibilities. I really encourage, if you did not play with this, to look at the Mikrotik site. There's so many other examples of how scripting was used to really create a very unique solutions. And then what would you like to report? That there was so many flexibilities. Like class of service is one of the things that we felt is kind of important, but you can do the many different things. Like even the drop, the interface errors, or this kind of stats are still available through the Mikrotik scripting and can be submitted as well.
Do you have a website?
Yes, from this morning. We just launched. This is Boom is actually our official launch date for Macrotik, and we've been keeping it only as a counter on our website until this morning. So we did just upload today. And yes, in terms of the cloud services, we're planning to introduce the beta. This is a kind of open source, as you can see, and you can freely download a few commands installed in any Mikrotik device and kind of get a sense of how it works. And it will be available before the end of the year. So you better, if you want to get access, just sign up on our page, and we'll send you the login.
What's the web address?
Mikrotik.com. Oh, I thought I had it here.
So,
Mikrotik.com.
interesting.
Yes,
You said it is launched?
Clever, yeah.
Sorry?
It is.
Well, we've been in this business for a very long time. This was really more around Mikrotik only specific build, just because of some capabilities, and we just launched it under this brand today. So, but there's a quite maturity in the systems and software that I've been talking about.
One thing I wanted to say, I love the idea of getting away from SNMP and hang. I mean, they're kind of primitive. Lack of encryption has always bothered me. And yeah, just I love the idea of going over 480 or 443 or whatever. But the massive storage requirements for the server, you said that you stored them in plain text, right? No SQL, is that translated just like
Oh,
text?
no. It's actually, it's using NoSQL database, or document-based databases like a MongoDB, or I don't know if you're familiar with there's a couple of them now from CouchDB or Hadoop, or there's a couple of others. They're built for what they call big data, when you have so much analytics, and if you Google it, you will find, and actually Google is one of the big one that they use for their storage, similar methods, and that was important.
Gotcha. So does that have like compression?
Oh yes, it has a compression, indexing, failover, automated failover, and it's definitely away from MySQL and Postgres and other traditional systems. So it took a bit of a learning curve to kind of go through the new way of storing data, but when you are centralizing the management and all these data, you have to be very robust and ability to scale. So Hadoop is good that you can kind of add the clusters of the storage dynamically, and it can be different machines, so you can definitely find more on the internet.
Any more questions?
Thank you.